My name is Hector Quintian and I'm going to present the paper with title Beta Hebbian Learning for Visualizing Intrusions in Flow. Here we are present the agenda I will follow in this presentation. We'll start with a brief introduction, we'll present the case of study, the model approach, and finally the results and the conclusions. Nowadays, technologies and strategies are continually evolving. So it increases the difficulty of protecting computer systems. Most of the artificial intelligence solutions are based on supervised learning. However, there are some unsupervised learning techniques applied for this purpose, especially the case of the visualization methods. As opposed to the supervision methods, in this case, it's not needed a previous knowledge of the data set. It's not needed to know if a sample is considered abnormal or as abnormal, which means an attack in case of cyber attacks. So this represents that in case of visualization techniques, we'll finally get a projection, especially in two-dimensionals, and we'll project the samples. So we'll represent the normal behavior of the system, which in this case will be represented with these blue dots, and some type of abnormal behavior or attacks, which are represented in this case with the red dots. So we can classify the techniques based on when we only have normal classes, one type of classes, only non-attacks. In this case, we apply the techniques of one class classification. When we have no previous knowledge of the data, we have mixed normal behavior and attacks, but we don't know which are attacks and which are normal behavior. Here we apply clustering techniques. And finally, when you have knowledge of these samples and they are classified or labeled as normal and anomalies or attacks. In this case, we apply the classical supervised learning for classification. So in case of no previous knowledge, we'll apply in this paper artificial intelligence visualization methods. Specifically, we'll apply the maximum likelihood Hebbian learning and the beta Hebbian learning, both belonging to the exploratory projection pursuit methods. The model approach that will follow in this research is start with the data set. In this case, we'll have 9 variables. We'll make a pre-processes of the data with a normalization between -1 and 1, and then we'll apply the artificial intelligence visualization methods. In this case, cooperative maximum likelihood Hebbian learning and beta Hebbian learning. And finally, this obtains a two-dimensional projection where we can see the normal behavior of the system and the attacks. In this paper, the two techniques applied are the cooperative maximum likelihood Hebbian learning and the beta Hebbian learning, both belonging to the exploratory projection pursuits methods. The data sets used are 4 data sets, which belong to the 20 data sets, and there has been divided in 4 segments. These are the 4 segments, and each segment has different number of samples and a different number of attacks, with 3 attacks, 4 attacks, and 2 attacks, 2 types of attacks. Here we present the first segment using this paper. We can see that in case of cooperative maximum likelihood Hebbian learning, the final projection of this data set after applying agglomerative clustering, we'll see how this method can easily differentiate the normal behavior, in this case the category number 2, the red squares, from the attacks, in this case the type of attack number 6, which are the blue and the green dots. So it is easily separated and clearly grouped. In case of beta Hebbian learning, it also can separate easily the normally and the attacks. So there is not significant improvement with this novel technique, beta Hebbian learning, respect to the cooperative maximum likelihood Hebbian learning due to the simplicity of the dataset. However, in case of the next segment, number 30, here we can see how there is a mix of classes, of categories. The normal behavior with category number 2 and the type of attacks, attack number 4 and attack number 8. So the attacks are mixed with the normal samples. For instance, in this case, we cannot separate the attack number 4 or this blue attack number 8 from the normal behavior, which is the green squares. So there are some parts of the dataset which are mixed in the final projection. However, in case of beta Hebbian learning projection, we clearly separate the normal behavior, the green dots, from the attack number 1 and the attack number 2, which has the red dots. So in this case, there are an improvement with respect to the previous method. In the next segment, which is more complicated to the previous one, here there are more mixed samples than the previous cases, so again, it's difficult to separate the normal behavior to the attacks. However, in case here the groups are more compact than in the previous one, there are samples which are mixed, for instance, in this case, with normal behavior and attacks. In case of beta Hebbian learning, the final projection does not mix these attacks, so the normal behavior green dots are separated from attack number 1, which is the blue one, attack number 2, which is the red one, and attack number 3, which is the cyan. So are separated all the samples, all the type of attacks. In case on segment 131, there are more mixed even than in the previous one, with the projection of cooperative maximum likelihood Hebbian learning. So in case of normal attack, category number 2, which are the squares, here in this part are quite mixed with the attack category number 6, attack category number 8, and attack category number 9. So most of the classes are mixed. So it's very difficult to separate or to identify when it's happening in an attack and when it's happening in a normal behavior. However, in case of beta Hebbian learning, in spite of the samples in this projection are quite sparse, all of the attacks are separated. The normal behavior, the blue one, attack number 2, the red one, attack number 2, and this cyan, attack number 3. However, if we're projecting three-dimensional, the final result is more clear than the previous one, where groups are more compact and clearly separated from the normal behavior and the different type of attacks. So, as conclusions, we can remark that the beta Hebbian learning clearly outperforms the results obtained by cooperative maximum likelihood Hebbian learning, especially when the complexity of the dataset is high or it is increasing, as we see in the results presented. It also allows to the user easy visual supervision because the samples are projected on two-dimensional datasets and can easily detect when there is attacks in the system. It is also a powerful tool, can be used for early identification of attacks, especially in the case of 0 days attack. And as the future work, we will test the novel beta Hebbian learning algorithm over new and more complex datasets with new type of attacks, especially in case of 0-day attacks. Thanks for your attention, and